Hey, and we're recording. You can see the chat right over there. I just finished the live stream. We're playing some chess and doing some math. So if playing some chess and doing some math sounds interesting, why don't you come out and hang out in the Twitch chat next time that I go live? Um, right about now and now and now, right? You should be typing in your last name, first name, and class period. Those questions are being prompted for you. Today we're looking at trigonometric ratios. You've probably looked at a calculator, whether your iPhone or a physical calculator, and you've seen those sine, cosine, and tangent. You've seen this sin, cos, and tan. You've probably seen that before. Um, what are those? Well, we're going to take a look at them today. But before we take a look at them, we're going to review the Pythagorean theorem real quick. Okay? The Pythagorean theorem says a squared plus b squared equals c squared, where a and b are the legs of the triangle and c is the hypotenuse. Okay? So if we were trying to solve for side c, we would do a squared plus b squared equals c squared, and we would take the square root to get rid of the squared, and c is equal to the square root of a squared plus b squared. What would we do if we were trying to solve for side b? We would do the same thing, of course, but we would need to subtract a over to the other side, and then take the square root. B equals the square root of c squared minus a squared. And then if we wanted to solve for side A, we'd one more time do the same thing, except we'd get rid of the b, and then we would be able to take the square root. So, something important to note, do you always add the square of the two given sides of the right triangle? No, we do not always add, right? In this case, and in this case, we subtract it, right? So which side are you looking for if you add the squared values? We're looking for the hypotenuse. And what are we looking for if we subtract the squared values? Well, we're solving for one of the legs. Okay, we're solving for one of the legs. So in general, right, hypotenuse equals the square root of leg squared plus leg squared. And if you're solving for a leg, well, its leg equals the square root of hypotenuse squared minus the other leg squared. Okay? That's kind of an easy way to generalize what we're looking at there. So let's real quickly solve these two. What are we looking for? We're looking for a hypotenuse, so we're going to add the squared values. So the square root of 15 squared plus 10 squared. You see, I'm just jumping straight to that very last line, okay? I'm not doing work beforehand. I'm just going to jump straight to that very last line. We end up with 15 squared is 225 and 10 squared is 100. We end up with the square root of 325. And if you plug that into a calculator, you can't see me doing it, but I'm going to do it real quick. The square root of 325 is 18.02. Although it says tenths place, so really just 18.0. Do the same thing. What are we solving for this time, though? We're solving for a leg, so we're going to subtract. It's hypotenuse squared minus other leg squared, right? This is the hypotenuse, that long side. So we end up with 13 squared is 169, 12 squared is 144, 169 minus 144 is 25, and the square root of 25 is 5. All right. All right, so let's move on to some new stuff. I'm not really going to dwell on that, right? So label the sides of the right triangle in relation to the marked angle. What are we labeling? We are labeling the side that's the hypotenuse, the side that's opposite of the angle, and the side that's adjacent to the angle. Opposite meaning across. Oops, that's still a highlighter. Across. How do I spell across? And adjacent meaning next to. Okay? So when I say opposite versus adjacent, you might have neighbors. You live in a house and you have neighbors. There's neighbors on the other side of the street, and there's neighbors to the left and right of you. Well, the neighbors that are across the street from you, they're on the opposite side of the street. They're across from you, they're opposite. And the neighbors that are right next to you, those houses are considered adjacent. That neighbor is adjacent to you on either the left or the right. So when we look at this angle, what is across from the angle? This side. That's the opposite side. What side is next to? This one. And which one's the hypotenuse? This one. Right? The long side is always the hypotenuse. You can just answer that right away. And then the one that's across is opposite, and the one that's next to is adjacent. The long side is always the hypotenuse, and then the one that's across is opposite, and the one that's right next to is adjacent. Okay, so let's have some questions pop up on the screen. This side right here is considered it's the adjacent side. I'm going to highlight this because last time I forgot to mark. Okay, we have a question about that, a question about this, and a question about this. So that way I know, because I have to add the questions after the fact, right? So I need to remember where they are. So that's adjacent. And this is opposite, and this is the hypotenuse. So looking at E, what side is this? Question pops up on screen. That's the hypotenuse. I would say the hypotenuse is the easiest one to label because, I don't know, it's the longest side. It's always the longest side. That's what the hypotenuse is. And what side is this one right here? It's once again the adjacent. And the one across is opposite, and this is the hypotenuse. We're not solving for anything here. We're simply labeling. Those are super easy questions, right? At least I'd like to think so. So, why do we care? What's the significance of opposite, adjacent, and hypotenuse? Well, that's the foundation of trig functions, of trigonometric functions. That's what these guys are. These are our trigonometric functions. So these functions are something specific used to right triangles. Okay, it's something that we specifically use for right triangles. So when given a right triangle, you can find sine of an angle. Sine of an angle is defined as opposite over hypotenuse. When given a right triangle, you can find cosine of an angle. Cosine of an angle is defined as adjacent over hypotenuse. And tangent is defined as opposite over adjacent. Okay? Do we need to fill in opposite, adjacent, and hypotenuse here again? Maybe one more time. Let's do it one more time. The hypotenuse of ABC, that's AB. The opposite of A is BC, and the adjacent side right there is CA. And then looking at the other one, the hypotenuse right there is DE, and then opposite of D is EF, and then adjacent to is FD. So the majority of our answers for sine, cosine, and tangent are always going to be fractions. They are defined as, it's a ratio. That's something else that they're sometimes referred to. They're like the trigonometric ratios, because it's a ratio of opposite to hypotenuse. It's a ratio of adjacent to hypotenuse. So when I give you a quote-unquote random triangle, and we're trying to find sine of A, well, here's A. The first thing that you want to do, number one, is to mark your HOA. Okay? So opposite of A is CB. Adjacent to A is AC. And the hypotenuse is 13. Okay? So we label them first, and then we just use these formulas, if that's what you want to call them, to answer the next few questions. Sine is opposite, 5, over hypotenuse, 13. That's it. Cosine is adjacent, 12, over hypotenuse, 13. Tangent is opposite, 5, over adjacent, 12. Boom, there's my 3 answers. Then it asks us to do the same thing, except do it for angle B. Okay, so I'm going to erase this because I don't want that to be a distraction, and we're going to look at angle B now. This is still the hypotenuse, of course, but now this side is opposite, and this side is adjacent. So when I do opposite over adjacent and whatnot, sine here is opposite over hypotenuse, so 12 over 13. Cosine is adjacent, 5 over hypotenuse, 13. And tangent is opposite over adjacent, 12 over 5. What do you notice? What do you notice here? They're flipped, right? The fancy word for that is reciprocals. What do you notice about those ratios? They are reciprocals. They're flipped. What do you notice? What do you notice about sine and cosine? And here, how about I make this the next question? I'm going to make a big yellow circle on this, so that way I know that I asked a question. What do you notice about the ratios for sine of A and cosine of B? What do you see? Type it in your own words. Here's sine of A and here's cosine of B. What do you notice? You should have just answered, they are the same. Yeah, they are the same. Sine of A equals cosine of B. Exactly. And what else do you notice? I'm not going to have a question pop up on the screen for this, but the same thing can be said about sine of B and cosine of A. Yeah, that's going to happen This is gonna happen every time. Every time. So we're going to take so basically when you've solved for one half, you immediately have the other half, right? Kind of. So let's watch it in action. Let's do it again. We're trying to solve for the hypotenuse. So a squared plus b squared equals c squared. When we're trying to find the hypotenuse, we already did several examples. We add the squared values together. So x equals the square root of 7 squared plus 4 squared. X equals 49 plus 16, which is 65. And we are trying to find sine, cosine, and tangent of r. Label. We know here's r, and we're trying to find sine of r. Well, sine is opposite over hypotenuse. We need to label that, okay, that's opposite because it's across. This is adjacent, and that long side is always the hypotenuse. And then we do opposite over hypotenuse. Okay? So why don't you pick, I'm going to have all three pop up on screen here. Here, here, and here. Why don't you try to solve for those real quick, right? You got the picture, and now we solve. I'm going to have those boom, 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 those three questions pop up on the screen. All right, so what should we end up with? Well, sine is opposite 4 over hypotenuse, root 65. That's what you should have typed for the first one, or multiple choice selected for the first one. Now you might be wondering, well, why didn't you just write it in the blank? Well, I'm going to add a little something something here. A little something something. In math, we don't like radicals in the denominator. Okay? So we must rationalize. That's the fancy word for getting rid of the radical in the denominator. And let me show you. How do we get rid of it? We multiply it by itself. When you multiply a radical times a radical, it just cancels out. And that is truly our correct answer, okay? And you will see it that way written on Canvas. So you should have already also answered your answer for cosine, and you probably chose 7 over root 65. 65, not 55. And we are once again going to multiply by itself to cancel out the radical. For whatever reason, I didn't choose this. I did not force this to be true. This wasn't my decision, but for whatever reason in math, no one writes radicals in denominators. It just doesn't happen. We get rid of it by rationalizing. So there's that. And then the last one, you already answered it as well. Opposite over adjacent, 4 over 7. Now, that required a little bit of work, but guess what? The other three we're already done with. Already done. Flip to find that, and then sine and cosine. Oh, if that's sine of r, well, then that's cosine of t. And if that's cosine of r, well, then that has to be sine of t. They simply switch. So once you do the first three, you immediately know the second three. And that comes back to what we said over here on the left, okay? Let's do it one more time. Let's do it one more time. Let's find this third side. That's a leg. So we subtract, right? That's a leg. So leg equals hypotenuse squared minus leg squared, which is 100 minus 64. So 6. And then we label. Here's A. So the opposite of A is 6. Adjacent to A is 8. Hypotenuse is 10. I'm about to have another question here in a second, so get ready. We're going to do opposite over opposite over hypotenuse for sine, so 6 over 10. Adjacent over hypotenuse for cosine, so 8 over 10. And opposite over adjacent for tangent. Okay, prompting a question now. Do I need to do to each of these? What can I do to each of these? I'm not quite done with these answers. All right, so you just hopefully typed a good thought there. You can reduce. You can reduce. I'm going to do another circle here, right? that there's a question there. Oops, that's not a highlighter. Okay, another circle there. We can reduce. So that's 3/5, 4/5, and 3/4. Right? We can reduce those by dividing by 2. And now that we have the first 3, all you got to do is flip it to find the other, and then these guys flip-flop. This becomes 3/5, and this one becomes 4/5. And again, why is that happening? I don't want you to be confused or like question why that's happening. It's just simply because opposite and adjacent are flipping, right? The second I say B is my angle, all of a sudden this becomes opposite and this becomes adjacent. That's why. The roles of O and A are switching, so therefore everything over here is also going to switch. And with that, we finished our 3-page notes. So thank you for watching. Thanks for answering those questions, and I'll see you in the next one.